Next question, number 18. The voltages developed across the 3 ohm and 2 ohm resistors shown in the figure are 6 volts and 2 volts respectively, with the polarity as marked. What is the power in watts delivered by the 5 volts voltage source? Okay, so here in this diagram we see that we have 2 networks, and between the 2 networks we have 2 resistors with the polarities. Now this is important, we'll have to note the polarity. So since the polarities are given to us, let's mark the direction of currents. Now we are supposed to find out the power delivered by the voltage source here. So according to the polarity given, I'm going to name this as I1. Here we have I2 and here we have I3. Note the directions. Okay, so let's take each branch. Now for this first branch here, we can calculate what I3 is because the voltage and the resistance are given to us. So I3 would be 6 divided by 3, voltage by resistance, and that's 2 amps. Similarly, we can find out what the current is passing through the 2 ohm resistor here, that's I2, and 2 divided by 2, which is 1 amp. Now we need the current I1 here. So we can find this out by using KCL. So Kirchhoff's current law says that the sum of the incoming currents equal to the outgoing current. So you're seeing the direction of the 3 currents over here. We can write down the equation as I1 plus I2 is equal to I3. Now let's substitute what I2 and I3 are. So that's I1 plus 1 is equal to 2, which easily tells us that I1 is equal to 1 amp. So we now have what I1 is. Next we can find out what the power is. Let me write it down here. Now the power delivered is just simply VI. Now V is the value of the voltage source, which is 5, and I is the current that is passing from it. So that's I1, which is 1. So power is 5 times 1, which is 5 watts. Well, the answer here is A, option A. Well, I hope this explanation has helped.